Okay, so would you read through it? Any? All of you have read it? Read the description, see if you have anything you want me to elaborate on. Read it line by line. Like in US and all, they follow 440 or 420. Okay, and 60 hours. So when you are traveling to those countries, right? So you have to carry adapters. Your devices won't work. Yeah, different adapters.
Those sockets are different.
Sockets are also different. So that's why in India, buy those sockets which will fit in their sources, and then you will be able to charge your device. Your device will function. But then if there is a voltage difference, then there is an issue. Okay, so there are devices which are designed at the time of manufacturing only, that care has to be taken, that it is functional and work, but generally it is not like that. That's how they kill competition. Like you will do a mass production of devices that are suitable for operating at 220 volt. तो तुम US में बेच ही नहीं सकते, उसमें तुमको एक अलग से फैक्ट्री डालना पड़ेगा. So you have to exclusively manufacture for them. तुम्हारा कॉस्ट डबल हो गया ना, कैपिटल कॉस्ट. तो तुम एक फैक्ट्री में चलाने के बजाय you have to maintain 2 assembly lines, different set of work processes. ड्राइविंग का भी वही किया है. We have right hand drive, therefore the left hand drive. So somebody came up with a tractor, middle. Take it to any country, it works. So how many of you are following the ISS trip of Shubhanshu Shukla? Have you heard about it? Are you aware that we have just sent an astronaut in space?
Yes, I
So you know Shooks. You might be knowing Shooks. I don't know why he is calling himself Shooks. It's Shubhanshu Shukla. Good, it is Shooks. If it is such, then completely different meaning. Okay, Shubhanshu Shukla is in this. So he is the first Indian to be on ISS. What's ISS?
International Space
International Space Station. So India is poised for big growth in research areas. It's a very bright future. Okay? Our country is finally opening up with some great opportunities. So we are putting up fabs. You understand fabs, right? How many of you are going to take science? Raise your hands. So almost everybody. She is non-science. Commerce. Commerce? Good. So we need commerce also. Who will pay salaries? Manage your money and all. So we need everybody. So lots of things are coming up here. So many of our research institutes also will come into 150, 200 rating. World rating game chalta hai. So they have decided everything favorable to them. Not like they're really great. Looted us, then built institutions, right? So we were like the good guys. The bad guys came over us, looted us, and then they have built infrastructure better than us. We accommodated them, but now we have become smart. We recently showed them with Operation Sindhu. So we have really killed not Pakistan. We have given good fitting to US actually. Okay, so they now are taking a seriously. Most of the research institutions are filled by US scholars and Chinese scholars. You should know this. And they are only running the management part of it. So what will you manage? Who will you manage? All the scholars are from Asia. करेंगे क्या फिर? So we have all the brain, and the reverse brain drain is expected to happen. Dollar is going to go down. The way they are fighting wars, every war each day it costs millions of dollars. तो आएगा कहाँ से? कहाँ से आएगा? And we fought war for 4 days. Okay, so finally our large population will become an asset now. There's so much of people to work on the ground. With all the artificial intelligence and all, what will they do? Who has created that artificial intelligence? Us only. तो आएगा अभी, ठीक है? तो तुम पढ़ाई करो ठीक से, फंडे ठीक से समझो, फिंगर मत करो इधर उधर. Avoid that. So live so that we can enjoy life. Huh? So anybody has any doubt in this? Did you read this? So we are planning to have our own space station. I'm not saying spacecraft, space station. So space station will always be in the space, and then there will be ferry service through our Gaganyaan. Which yarn we have taken right now? What is the spacecraft? Anybody remembers? Dragon. The capsule in which they sent. And that Dragon was of Tesla, SpaceX. So follow this, it's very exciting. Shall we start discussing the questions if you don't have any doubts? You have any doubts in this? The last topic. Everybody went through the last topic? See if you need my help anywhere. So the word plug and socket you understood, right? This thing is called socket. Then the plug docks into the socket. So plug will have pins. This. So let's begin with the questions. Okay, the first one. Name the first one. Name 2 safety measures commonly used in electric circuits and appliances. Earthing and
Fuse wire.
fuse. Earth wire and fuse. Second question. So who would like to answer?
Sir, the appliance would break,
Appliance would break.
or it would. So the appliance won't start.
It won't start. Why?
Sir, because the power. Sir, because it is impossible for the oven to achieve sufficient power
It exceeds the safety limit.
It exceeds the safety
It
limit.
will like break or
Yes, it will melt the fuse wire. What is the rating? 5 ampere. That means the domestic wire is not allowed to carry current over 5 ampere. Which means when will you enforce that? When will you enforce that? By connecting a fuse. Because the moment current goes above 5, the fuse wire will melt. So 2 kilowatt electric oven, how much current it will draw?
It could draw only up until a maximum of 1100 watts.
That's current or power?
Power,
So what is current?
current, it would drive to
What is the formula for power?
voltage into current.
Current. So what is current? P by V. So what is the power here?
2000 watts.
2000 watt. And what is the voltage here?
220.
220.
so that's subject 9.
So how much ampere you get?
9.
100 by 11. So 11 9 is 99. So it is in excess of 9 plus ampere.
Right, yeah.
So will the device work? No, the fuse will blow off. Okay? So this is the thing. So the device won't work because the current exceeds the rated current that wire can carry. Understood? So such kind of questions might be asked. Okay. What precautions should be taken to avoid overloading of domestic electric circuits?
Implementing fuses.
MCB. Yeah.
Implementing fuses, yes. So, but how overloading takes place?
Overloading. A sudden increase in the supply of voltage.
This is overloading. The rated was 5 ampere, but you overloaded it by connecting a device which needs more current than the rated current that the wire can carry. This is the example of overload.
So when a live wire and a neutral wire come in contact,
That is short circuit. That's short circuit. This is different problem. This is not short circuit. This is overloading. So by implementing fuses is correct. Okay, or by using the device which draws current below the rated current, equal to or below the rated current. Okay, what is rated current? Like this, you have fixed a fuse of 5 ampere. So no current more than 5 ampere will flow there. Is that clear? Okay, next. So are you reading the textbook? You must read the textbook. Okay? Are you reading or you are only reading the volume? Volume is good for revision. If you want to increase knowledge, want to have the right perspective, also read the textbook.
Why can't two of these lines meet each other?
Why can't?
Two meet lines.
Which
What
field
would
line?
magnetic?
What would happen? The way it is designed, you can't like that. If the field line meet, right? Let's say meet means it can be highly close, parallel. That way. They can be together.
They cannot come in contact.
No, they will not cross each other. See, it's a visual imagination. So it's a continuous field. So where the separation starts, you can't really define. Because you can just go thin, infinitely thin, 0.00000001 millimeter. Now, what length is that? It's inconceivable. Okay? Because the field is available at every point around the source. So that is just for our sake of understanding. But then you can't have 2 feet and crossing each other. That's not allowed. The dimension can be very small, the length dimension. It is up to your imagination. Okay, so read all this summary and all this is good for revision. Okay, let's quickly run through this. Which of the following correctly describes a magnetic field near a long straight wire?
D. The field consists of concentric circles and one wire.
Yes. Okay. Next. Everybody agrees with this?
Yes.
Next.
C increases in
Yes. Okay. So during short circuit, the resistance is very low. Zero resistance. So I is equal to V by R. R0 means I becomes infinite. Okay. So which is true or false?
was just always.
The field at the center of long circular coil, that means solenoid. Long circular coil is
True.
solenoid. Current will be parallel straight lines.
True.
It is true.
Second
is false.
Second is false.
Second will be
False. False. False.
so what wire is this?
False.
R. Okay. List two methods of producing magnetic field.
Rubbing and electric. Passing electricity.
Solenoid. One is solenoid.
And the other is passing current through a straight wire.
Yeah, I mean different configurations. Okay. So through a solenoid or through a straight wire. Just different current configuration. Just think about it. In a loop or in a coil, everywhere you will be able to produce magnetic field. Okay? Fifth. When is the force experienced by a current carrying conductor placed in a magnetic field largest? Perpendicular. When the current carrying wire is placed perpendicular, let's say this is the direction of the magnetic field, and if the current is also in the same direction, then it will not experience any force. If the current carrying wire is 90 degree, maximum force. If it is like this, force will be less. It will experience force, but not the angle. Angle between the field and wire. So at this angle, maximum force. What is the force direction? What is the force direction? Left hand rule. This is red current direction. This is field direction. Where is thumb? Yeah. So if the field is coming towards you, wire is current carrying like this, then it will be pushed in this direction. Will field stop the wire? These are imaginary lines, so many fields. So it will move like this. This is a physical, it's not physical, I mean, not any hindrance, it's a field. Okay. So it will move towards left. Okay, next. Sixth, everybody read question 6. Feel free to ask questions, huh? Don't be shy. Later on, so we are almost reaching the end of the physics course. Physics course itself, only one more chapter remaining. This is the time for you to feel free and ask. By now, you should have become comfortable with me. Okay? So the opportunity is just running out too fast. So feel free, have your questions, ask. And even when the course is over, you can demand for extra lecture in case you need. But for that, read. Otherwise, you won't have any questions. Reading is absolutely necessary. Next question. So, are you able to visualize? So this is the back wall. Let's say this is the front wall. So the electron from the back wall comes here. What is it? Electron. And it hits the front wall. And it's deflected by a strong magnetic field towards the right side. So let's say it is deflected on this side. Okay, this is the direction of force. Obviously, it is deflected on the right side. Now, what is the current direction then? Opposite to electron direction. So then, what is asked? What is the direction of the magnetic field? So what is? So you have to align I and F. Where is force now? Right. Current is towards you. So how will you do? Force is right. And where is the current? Like this. Okay? This is current. Force is towards right. So where is the magnetic field? Downwards. Got it? So only two directions will be given to you. The third one you have to align and find out. So it could be tricky. So some practice will be required. Some people just stretch hands too much that they suffer sprain. So just practice it. है ना? कैसे करोगे? कोई दो अलाइन करो. फोर्स राइट में गया है, करंट तुमको पीछे लाना है. तो फोर्स फिक्स रखो. This becomes the axis. ठीक है? करंट पीछे है. Then field is gone. ठीक है? Okay. So is that correct? Check the answer at the back. बुक के एंड में होगा. बुक के एंड में. Chapter number.
Yeah, I found it. Magnetic field inside the chamber is vertical to the direction of.
Where? Downwards? What is given? Vertically downwards? Yeah. Yes. So that's correct. Okay. Next. What's the rule? First rule.
Right hand thumb.
Right hand thumb rule. Second. Fleming's left hand rule. Third. That's out of syllabus. So this is a copy paste error. Okay. Current induced. Wherever you find the word induced, that's not in syllabus. Okay. You have not studied this. Third is out of syllabus. When does an electric short circuit occur?
Due to high electron supply.
When the live wire accidentally comes in contact with neutral wire. Okay? What is short circuit? When the live wire accidentally comes in contact with neutral wire. That is short circuit. What is the function of an earth wire? Why is it necessary to earth metallic appliances? Does that answer? We explained it in detail. Okay? To avoid electric shock. Yes. ठीक है. अगर अर्थ वायर नहीं हुआ तो तुमको इलेक्ट्रिक शॉक लगेगा. ठीक है. डिवाइस चलता रहेगा. थोड़ी देर के बाद डिवाइस भी खराब हो सकता है. Because the energy is distributed through the device. All right. Let's do some classwork questions. Let's quickly go through it. Come on page 170. So one more question. What is an electromagnet?
Electromagnet of powered by electricity.
Like current carrying solenoid acts as
Electromagnet.
magnet powered by electricity. Yes, that's also correct. But this will be more articulated, है ना? Okay. Second question. So we take turn, right? So let's start. Second question. Read.
When can an electric charge give rise to magnetic field?
Yes. When can an electric charge give rise to magnetic field? When it is in motion. Only current can produce magnetic field, right?
Yes.
So when charge becomes current, when it is moving, isn't it? What is current? Rate of flow of charge. So when charge flows, that's when electric current is produced. So the answer to the second question is when the electric charge is in motion. Third question.
See the direction in which the needle will turn in the
Given diagram. So what is the given diagram? You have a current here and the magnetic compass. So what is it? This is north pole is here and the south is here. So what will be the direction of in which the needle will turn? So this is, let us say this is the current flowing here. Okay, and you have a magnetic compass here below. Okay, so current is flowing here, so it will produce magnetic flux like this. Okay, right hand thumb rule. What is the magnetic field? Concentric circle like this. So it will deflect. So where is the north pole? So here also the magnetic flux, so north will come here. Okay, so this should turn like this. So it will turn clockwise. How it should turn? Clockwise.
Please read it again.
Huh?
Please read it again.
This is the current direction. So how is the magnetic field? Like this.
No.
The magnetic field is like this. So this field will repel the north pole. Where is the north pole? Towards me. So it will repel it like this. So where will it rotate? Like this.
This.
So anti-clockwise. This is what anti-clockwise. When you see it from here, clockwise. It will be clockwise. No, this is clockwise.
Yes.
When you see it from the top, how it will appear? Clockwise. How is the field here? So it will repel the north pole, na? So north pole goes there. So in the plane, in the horizontal plane, how the magnetic compass will begin to rotate? Clockwise. Where is the current direction? See the diagram, current direction now. So
Anti.
not the field. This is the electric current, okay? How is the magnetic field direction? Like this. Like this. Concentric circle. Okay. Now, the magnetic compass is kept here. So north pole, no? This is south pole. This south pole. So this will repel north. Where is the magnetic compass? It is in the horizontal direction, like this. And where is the magnetic field? It is in the vertical plane. Understood? There are two planes here. The magnetic field is in the vertical plane and the compass will rotate in the horizontal plane. So this will actually rotate it. Where will it be deflected? In this direction, no? In this plane.
And when the current direction is changed.
Then it will be anti-clockwise.
Anti-clockwise, right?
If the current is in this direction, then it will begin like this, opposite. Is it making sense to you? No. Imagine This is the compass surface. Okay, this side is north, this side is south. Current is flowing like this. So when the current is flowing like this, so how is the magnetic field? Like this. Magnetic field is north to south, na? Means it is north. So north, it will affect the north. It will repel the north. So north now goes here. So what is it? Clockwise. Okay? That's how it is.
If the
You are taking left hand.
No, if it reverses, it will be anti.
Still it will be right hand, like this, not the left hand. The rule has to be applied using right hand only, like this. So now, you only take this field with the north, don't take it with the south. Only see if the fingers are tipped, where the tip of the finger will displace the north pole. Where is the tip going? Tip will displace north pole now, anti-clockwise. So the answer in this case is clockwise. So there are no numericals. It's application of rules. Okay. So got to be very clear. Okay. Next question.
Anti-clockwise.
What is next question?
What is the observation current is reversed?
Oh, that is what she asked. I thought she asked herself. That was next question, right?
What's next question? Okay.
She asked that. So okay. So next question it will be
Anti-clockwise.
anti-clockwise. Okay. Question 5. Shall we? Okay, you take question 5.
What is the polarity at B in the figure alongside with the keys close? It will be south pole.
South pole. Everybody understands? It will be south pole. Correct? Like this is the positive terminal, so current goes up. So when you apply the right hand thumb rule, or see from here, this is clockwise current. Okay, when you see in this direction, the current at B is clockwise. Clockwise current is south. If this is south, this has to be north. This is south. Okay. Okay, next. Next is
If a soft iron core is inserted in a solenoid, what happens to its magnetic property?
increases. Okay, when you insert a soft iron core, the magnetic strength will increase.
So when the magnetic field is clockwise, so that it would be
Magnetic field is clockwise. Where?
in a bar,
Straight bar.
like in a solenoid.
Solenoid with the magnetic field will enter through the south pole. Current is clockwise, you can say. What do you mean?
In a loop.
In a loop, when the current is clockwise,
So that would be
south pole.
south.
When you are seeing and the current is clockwise, then the magnetic field is south pole. Field will enter there. And if the current is anti-clockwise, when you are seeing the loop, then the field will come towards you. Okay, clear? Within the coil, I am talking within the coil. Outside is opposite. So everybody is with me till question 6. Keep noting on your volume whatever answers I am telling you. Now check the following statements. Write true or false against each.
False.
Take Anushka. Check the following.
7A, like magnetic poles attract each other, unlike poles repel each other, it is false.
It is false. Next. No, you only take.
If you strike a sharp edge of a metallic knife against the north pole of a magnetic bar magnet, it will induce. So it is not there in the syllabus. Induce.
So, not induce electric current. This is magnetism. So this is about what pole will be developed. The opposite pole, generally.
South, right? So it's
South, opposite. If you are hitting it, it will develop an opposite pole. Okay? So that it will then be attracted.
so the CPAP
If you strike a sharp result against the north pole, it will induce a north pole. No, it will induce a south pole. Okay. So B is false. C,
the magnetic field produced by a current and straight wire has no poles. False, right? True.
can you? Yeah, it's true. Straight wire is the only current configuration in which you can't identify the poles because now the field is circular. Okay, so from where it is emerging and where it is merging, here the field is outside. Okay, and the wire is straight. So poles are not visible in this case. For poles to be visible, the wire should be in the form of a loop or a coil. So in a straight wire, there is no pole. So it is true. Okay, next. Question 8. So it is not in syllabus. Electromagnetic induction is
I'm reading the next.
Actually, it is totally.
I am reading the online magnetic field.
okay.
So the space around a magnet,
What are the magnetic field lines?
the space around the magnet is the magnetic field, and the line.
Space around the magnet where any other magnetic
Is
substance
the magnetic
is,
field.
experiences the.
Exits of the line. So they are the magnetic field.
Okay, so you know it, right? So articulate it well. How is the direction of magnetic field at a point determined?
When the north pole is the needle is reflected.
Yeah, so you can place a magnetic compass there. So wherever the magnetic compass points, that is the direction of magnetic. Then mention 2 important properties of magnetic field lines.
The two poles are equal straight.
The magnetic field lines are strongest near the poles and they cannot intersect each other. Okay, ठीक है, ये दो तो लिख देना. And third is emerges from north pole and merges into south pole outside the magnet and inside the magnet from south to north. Emerges नहीं, south में तो merges. Inside the magnet, south to north.
And they never intersect.
That we discussed. Chalo, whom should I? Yes, you take the next question. Name the device.
Name the device used to measure potential difference.
Voltmeter. V लिखा रहना. Voltmeter. Okay. What is the device to measure current? Ammeter. A. ठीक है? All right. Yes, you take it. Next question.
The figure shows the direction of current in a straight conductor. Show the direction of lines of force. Just a second.
So when they say lines of forces, magnetic lines of force.
So,
What is
sir, we use Fleming's left-hand rule over here.
Left hand rule. How?
Because sir, the direction of current
Where is the current flowing? In straight wire or?
in a straight line,
Yeah.
Concentric
in a concentric.
It will be concentric circle, right? So that circle will be what? Clockwise or anti-clockwise?
It should be
Huh?
anti-clockwise.
Anti-clockwise. Because the current is coming towards you. Anti-clockwise. Yes. Okay. So here, don't get confused. It is not kept in any magnetic field. So here, line of force they have said. Actually, they should have said magnetic line of force. That is also wrong actually. It is a wrong way to put up the question. But hope you understand, it will produce magnetic field lines which are anti-clockwise. Okay. Short answer questions. How will the magnetic field set up? Question 12. By a solenoid chain when the current is decreased. Who would like to answer? You answer.
When is decreased, like when the current is decreased,
Magnetic field strength will also decrease. When the soft iron is
Increase.
it will increase.
yes. Okay, everyone got it? Okay, strike out question 13. It's not there. 14th, you give two differences.
Electromagnets and permanent magnets. Permanent magnets remain as have magnetism.
They have
Electromagnetism
static magnetic field. So you can't alter the magnetic field.
and electromagnets will only return the magnetism as long as current is passing through them.
Yes.
You can adjust the strength
Yes.
in an electromagnet, whereas in a permanent magnet it has constant magnetic field strength.
True. Correct. Okay, so two properties. Then you can change polarities. There are many things possible. You can. How can you increase by increasing the number of turns, increasing the current, and inserting the soft iron? Okay. Then, so I think everybody knows this. Question 15. Draw a diagram to show field lines of magnetic field through and around a solenoid carrying a current. So everybody comfortable with this? Huh? Solenoid carrying a current. Can you draw the magnetic field lines?
Yes.
Okay. Same like bar magnet. Okay. So I'm just going ahead. So question 16. Everybody do in your notebook and workbook. And then let me know once you're done. So the diagram is given next to question 16.
So, you have this one.
You don't want this? No. So what is the polarity of A? South. Looks south, clockwise current. Why does end A and B behave as magnets?
So
Because they have properties similar to a bar magnet. Okay. Because A is a clockwise loop, B is a anti-clockwise loop. So both produce magnets. Who discovered this effect? So what should you write the answer for 3? Because a current carrying loop behaves as a magnet. And 4, who discovered this effect? Who discovered magnetic effect of electric current? Oersted. Okay, Oersted. Generally these questions may not be asked, but keep. Now the questions are more of application, like question 3. State the direction in which needle will turn. Those are application. अभी किसने क्या बनाया था? आ भी सकता है ये level में. Question 17. On what factors does the force experienced by a straight current carrying current placed in the uniform magnetic field depend? The magnitude of current and the angle between the current and field direction. You get two things. The magnitude of current and the angle between current carrying conductor and magnetic field. Sure. With this we come to 3 more questions. We have 33 questions. Let's go quick. On what factor does magnitude of induced charge? So 18 Norden syllables. State the factors on which force experience. Already done. 19 is same as 17. 20 Fleming's right hand rule not in syllabus, left hand rule in syllabus, thumb rule in syllabus. Which of these laws are most suitable for finding direction of magnetic field in a straight color? Which rule? Thumb rule. Yes. 21 not in syllabus. 22 not in syllabus. 23.
We have discussed that.
We have already discussed short circuiting overloading. 24 we know. Describe the action of electric fuse. We know electric fuse. Okay, it melts as soon as the current flows higher than the rated current. Okay. So 25.
So I have a question.
25. What happens if fuse wire is placed in parallel in your household wiring? Somebody had a question?
Yeah, I had a question.
Hmm.
Let's see. Describe the action of electric fuse. So it's like a one-liner.
Describe
Describe the action of an electric fuse.
Ah.
It's a one-liner answer.
what is it?
Basically, it's like you overuse it. It's like
During overloading and short
Yeah, I know
circuit,
that.
it will
But you
melt.
get 3 marks like essay. Like writing one line, you get 3 marks.
Maybe you write 3 points then. Like write some property of a fuse wire. It is a alloy made up of lead and tin or lead and iron. It has a low melting point and high resistivity, right? And third, it melts whenever the current flows in the circuit higher than the rated current. Okay, ये दो तीन चीज लिखते हैं. Okay, so it is a safety mechanism. Some blah blah blah. Where were we? Question 25. What happens if the fuse were placed in parallel or series? Series. You saw that, right? Everywhere the fuse wire is in live, in series. So parallel में होगा तो फायदा ही नहीं है ना कुछ. Each device still will keep getting full electric potential. So it won't act as a safety mechanism. Okay. All right. Question 26. Two fuse wires of same length are rated 15 ampere and 5 ampere. Which of the two will be thicker and why? Which wire will carry more current? The one with less resistance. So what is the relation between resistance and thickness cross section? Inversely proportional. So current will be more where the resistance is less. So which wire will be thicker? 15 ampere or 5 ampere? 15 ampere. 15 ampere will have less resistance because high current is flowing. Okay. All right. Who discovered magnetic effect of current? Done already. Name the rule used to find direction of magnetic field along straight wire, right hand thumb. Mention two important properties of magnetic field lines. So we have already done this. 28 Norden syllabus. 29. We have already done this activity.
Yes.
Okay, this is exactly the activity that we have done. 30. Do you want to repeat 29? Everybody, those who did not get it the first time. Anybody want to repeat 29 can repeat it. So only what is not given is, this is the horseshoe magnet. The lower one is north, the upper one is south. Okay, so you can just label it. Lower end of the magnet is north, upper end is south. Then you'll get to answer. Then it becomes exactly same as the activity in your book. 30. With respect to magnetic effects of current, answer the following questions. happens to magnetic deflection when the current is increased? The deflection increases. Okay. What happens to deflection of the magnetic needle if the wire is moved away from the needle?
Deflection will decrease.
Decrease, because when you take it away, the magnetic field strength reduces. Because current is kept same, so magnetic field will reduce. Okay, C. What is the direction of deflection of north pole of the magnetic needle in the given diagram? Similar to question 3.
Clockwise.
Third question also clockwise, this also clockwise. The poles are reversed. So you follow the tip of the finger, how the tip is reaching the north. So it will deflect the north towards the left, below the wire. So which means it is anti-clockwise. D. D is right hand thumb rule, straight wire. Okay, 31. Identify two objects shown below.
Magnet solenoid.
Yeah, bar magnet and solenoid or electromagnet. Huh? To give any two differences, already we have done. Now, how do you answer question 32(1)?
32.
Question 32, first part. The direction of deflection of the north pole of a compass needle kept at a given point near the conductor remains unaffected.
Statement 2 is incorrect.
Hmm?
And statement 2 is incorrect.
Which one is correct and which one is incorrect?
Statement 1 is correct. Statement 2 is incorrect.
Statement 1 is incorrect. No? Statement 1 is incorrect. Read the full question. The 1-2 part mein, the question is in the end, which of the above observation of the student is incorrect and why? So it says, a compass is kept here, right? Now when the direction is changed, then the compass remains unaffected. ऐसा तो हो नहीं सकता. You have the nature of it changes with the direction of current. So the magnetic compass cannot remain unaffected. So statement 1 is false. Second, वो बोल रहा है, for a given battery, the degree of deflection of the north pole decreases when the compass is kept at a point farther away. दूर लगी रहे तो magnetic field strength decreases. So this is okay. This is true. Okay. So second is true. First is false. Okay. This brings us to the last question of the classwork exercise. Identify the type of current in each case. So first current is AC alternating. What about B? No. Do you have an alternating direction? It is in the same direction. But this is a like rectified output. Like I said, no, when you charge a mobile, right? So then what do? You convert it from AC to DC. So this is AC to DC converted current looks like this. Whenever the current is converted from AC to DC, so it is a pulsating DC, it is called. Okay? So this needs to be filtered to make a smooth DC. Now that is a topic in curl standard. ये सब क्यों दे के रखा है मालूम नहीं. Okay, so with this we have completed the classwork, and if you have, we have few minutes remaining. If you have any question, you can ask. Okay, in the next class we'll start with the last chapter, which is human eye. Okay, that's a small chapter. I think 2-3 lectures will complete it. Then it will be good to write 10th board exam. So if you have any questions, doubts, we have 3-4 meetings ahead. So write from any topic. We have only 4 chapters, right? So you just bring any questions, we'll sort it out. Okay. So just go through what we have discussed today. If you have any questions, you can ask. So how is electricity? Is it better now?
Yeah.
Initially you said it looks very good. Now it's okay. But questions, the way it will be twisted and asked now, so you have to practice that now. So have as many questions, like all of you are doing abhyas?
Yeah.
You're doing abhyas? Is it, how is the nature of questions in abhyas? Okay, and textbook questions, have you tried? Are you doing this exercise that you are from mixed school? How many school students are here? So everybody exchange papers. That will be extra practice. For the same topic, okay? So you may have friends, right? Friends studying at other school. Exchange papers. So you have, question bank with you. So you will have idea of variety of questions, expected questions. Do that. Okay? But volume also have enough questions. So you can do that also. And for recent variety of questions, exchange papers from your peers. That will give you enough practice. Okay, so with this, I think we'll stop it. I'll see you in the next class.
वो देखती है